Hello friends. This video is brought to you by mywayteaching.com.
Now let us move to another measure of congruency of triangle. Suppose I give you one triangle and ask you to draw a copy of it, or in other words, to draw a congruent triangle to it. You already know that giving one side is useless, as many triangles can be drawn on the same base. Now, suppose I give you another information. Say I give you that one of the angles of my given triangle is 65 degrees, then can we draw a congruent triangle to it? No, we cannot, because we can draw many triangles who can have one of the sides to be 5.5 centimeters and one of whose angles is 65 degrees, but still they are not congruent to our given triangle. That means some more information is required in this triangle so that we can draw a congruent triangle to it. So let us modify our statement. In this triangle, the length of two sides, say this one is 3.4 centimeters, is given, and the angle between these two sides is given, then let us see if we can draw a unique triangle which is a copy of it. Let me draw a line segment BC 5.5 centimeters in length. Now let me draw a 65-degree angle at B. So using a D, we have drawn a 65-degree angle at the vertex B. Now it is given that the side that is included with the angle is 3.5 centimeters. So let us use the ruler and mark 3.4 centimeters arc on the line and name the point of intersection as A. Now if we join AC, we get a triangle ABC which can completely overlap my triangle and which is congruent to the given triangle. Hence, if side, angle, side is given to us, then we can draw a triangle which is congruent to it. Hence, we state that if under a correspondence, two sides and the angle included between them of a triangle are equal to the corresponding sides and the angle included between them of another triangle, then the triangles are congruent by SAS property. Same result can be stated as SAS congruency rule. Two triangles are congruent if two sides and the included angle between them of a triangle are equal to the two sides and the included angle of another triangle. Note that this result cannot be proved with the previous known results, hence it is accepted as a true axiom. Let us read the question. In the given figure, OA is equal to OB and OD is equal to OC. show that triangle AOD is congruent to triangle BOC, and secondly, AD is parallel to BC. Let us start with the proof that the two triangles are congruent. So, we start with that n triangle AOD and triangle BOC, OA is equal to OB and OD is equal to OC. This is given. Also note that angle AOD and angle BOC are vertically opposite angles, and so they will be equal. So let us write that angle AOD is equal to angle BOC since they are vertically opposite. And this implies that triangle AOD is congruent to triangle BOC by SAS property. Now it is very easy to prove the second part, that line AD is parallel to BC. Clearly, since the two triangles are congruent, so by CPCT, all the corresponding angles and the lines are equal. So that would mean that angle A will be equal to angle B. So we will write that angle OAD is equal to angle OBC by CPCT, which says that corresponding parts of congruent triangles are equal, so the angles will also be equal. But angle A and angle B are also the alternate angles, so we can say that AD is parallel to BC. Hence we can say AD is parallel to BC. Let us read the question. AB is a line segment and a line L is perpendicular bisector of it. If a point P lies on L, show that P is equidistant from A and B. In other words, we have to prove that AP is equal to BP when L is perpendicular bisector of the line segment AB. We are given that L is perpendicular to line segment AB and it passes through C. That means C is the midpoint of AB and AC is equal to BC. We have to prove that PA is equal to PB. Clearly, if we can prove these two triangles congruent, then by CPCT, the two sides will be equal. So let us first check the correspondence. Clearly, C is a common vertex and P is also a common vertex. So the correspondence has to be that A corresponds to B, C to C and P to P. So let us check the triangles PAC and PBC. We have AC equal to BC, which is given as L is perpendicular bisector of AB. Then angle PCA and PCB is 90 degrees. This is also given as L is perpendicular to AB, and the side PC is common, so we can say that PC equal to PC. It is a common side. Hence the two triangles are congruent by SS property. So triangle PAC is congruent to triangle PBC by SS rule. Now since the triangles are congruent, so the corresponding sides of congruent angles will be equal, and this would imply that PA equal to PB by CPCT. That is corresponding parts of congruent triangles. Hence we have proved the required result.